So let us take some combinations. Let us put the amplitude 1.25, frequency as 6, initial phase let us put as some number, the amplitude of the second oscillator as 2.33, frequency of second is 4, and this is about 1.8. So first let us see how the individual oscillators look. So this is the individual oscillators, this is the first one and this is the second one. Now let us look at the combined one, or even before going to the combined one, let us see what happens to these arrows as a function of time. You can see the phase difference between the arrows is changing as a function of time. And the trace, which is the combined one, is no more a circle. See, the phase difference is out of phase. Sometimes it will be in phase, sometimes it will be out of phase. So when the frequencies are different, the first thing that happens is the instantaneous phase difference is a function of time. Out of phase, let me remove the trace and let us look at the combined one. So when we take a sum, it is the vector sum of these two vectors. So as you can see, you can slide this vector, put the end of second vector on this, and the arrow of the second vector would touch here. So this is the usual vector addition. So each instant of time we have to perform the vector addition. So this is at t equal to 0. Let us see what happens at another time. So we can see the length of the arrow is changing. So that means the motion is no longer a simple harmonic type of thing. So let us observe this full thing as a function of time. Observe the length of the arrow and its angle with respect to the other vectors. Both in phase, the vector length was maximum, and vector length is changing as the angle between both vectors is changing. Now observe, they will be becoming out of phase. Yeah, now they are out of phase. So that was the minimum amplitude. Again it is increasing. So the tip of the vector is not going on a circle. That means it is no more a simple harmonic vibration in a strict sense. With the it will not be possible to describe this motion in 1 cosine omega t plus phi. That is the another meaning. So to end the simulation, let me put both the amplitudes as same, equal, and put the frequency as 8 and this frequency as 2. Initial phases are something, and I will put the trace also. It would be interesting to see how the trace line will be. So this is at t equal to 0. Let us change the phase actually, so that it becomes, yeah, so let's put the phase as something like this, and let us observe what happens. So in this simulation I have shown how the rotating vectors concept can be used to describe the superposition of harmonic motions. When the frequencies are equal, we have seen the length of the arrow remains same, meaning that the combined motion would occur with the same frequency as the individual vibrations, the initial phase and the amplitude depend on the initial phases and amplitudes of the two vibrations in this case. And when the frequencies are not equal, the important difference which you observe is the angle between the vectors, that is the phase difference between the two vibrations, is a function of time, and the combined motion no more occurs on a circle. It takes some different forms. So remember that that would mean that a xt graph is no more a cos omega t kind of a graph. It would be some complex combination. Thank you for watching this video. I hope you liked the explanation of the concept.